As a review, can you guys please find the derivative of the first two columns on the top of the page? So find the derivative. It's even labeled what to make sure you use.
I'll find the derivative. I'm so confused.
Can't use it. Okay, fully. Chain rule tells us you take the derivative of the main function times what?
Inside.
The derivative of the inside. What is the derivative of this inner function?
6x.
Simplifying it together, you could have what, like 42x, and then that parenthesis. On the second one, the place that squared is it saying the cosine value is squared or the x is squared? X is squared. Remember, if it was the other way, it would be right there. So what is the derivative of cosine?
Negative sine x squared 2x.
Perfect. So when you have composite functions, you have to use the chain rule. What we're going to learn today is when you integrate, you really are using the chain rule all the time. So we're going to see like what if you have a function that has a derivative on the inside, how does its integral look different? Before we go on to that one, okay. What's the derivative of x cubed dx? Or sorry, what's the integral?
1 from x
Plus.
C.
Alright, so if this is a relationship, how can you always check your answer?
Take the derivative.
Take the derivative. So what's the derivative of 1/4 x to the 4th? What's the derivative of the constant? 0. That dx, what is dx?
Change of x.
Change of x. This,
The width.
isn't it also stand for the derivative of x?
Yes.
The chain rule is already built into this problem. Do you agree that the derivative of x is dx?
No.
Yes. So when you integrate something, you need to have its derivative there with it. Everything you've seen up to this point, I went to the dentist this morning and my lip does not work anymore. I hate the dentist. I don't
recording.
It is so, that's fine. You guys, it's fine.
Well, you're in the recording.
So, the one that's in your guys' notes. If you look at that integral that you're being asked to take, there's an extra piece in it. What's the extra piece of it? There's an extra 2 in there. So that 2, it comes from when you take the derivative of this, what comes into play? The chain rule. So because of that fact of, if you were to go back and check this, you'd have to be able to take the derivative. When you integrate something that has an inner function, its derivative also needs to be there. Because what is the derivative of 2x? 2. So the derivative of this inner function is 2 dx, because it's just an x in there. So what we're going to learn is use substitution of how you can find the integral of things that have composite functions. So it got really smushed for you guys because I wanted to keep it all on one page. This very top one, you can't find the derivative or the integral of that. The reason you can't is why? It's under, what's under the square root? The stuff, x squared plus x. If you wanted to be able to find the integral of that, its derivative needs to be present in the integral. So what is the derivative of x squared plus x? So if you wanted to be able to evaluate that integral would need a 2x plus 1. So these are composite functions. How do you integrate something with composite functions? That's what we're going through today. What it looks like is if you're taking the integral of f of gx, this dx part is the derivative of the inside. So you also need the derivative of g prime of x. We're going to use some u substitutions. So the left side and the right side of that are the same. It's just one of them uses gx. The other one just uses u. Because if you have a u, what's the derivative of u?
Du.
Du. So the derivative there is still present. All right, we're just going to jump into it. Write that in terms of u and du. First, identify what your u is. U is the function on the inside. So what is our u term?
G squared plus 1.
Yes, you are. So u is x squared minus 2. Then evaluate and find what the derivative of u is. So what is du? 2x. We're going to do some u substitutions so that you can evaluate this integral. Using that u, how would you rewrite that? Yeah, it's u cubed. Now, technically, chain rule in effect, the derivative of x squared is 2x dx, because we're taking the derivative with respect to x. So this whole piece right here, 2x dx, what does that equal? That's du. So magically, we were given something that was pretty much set up for us. We can now integrate that because we have u and we have that du, which represents its derivative. What is anything to the third power when you integrate it? It would be that thing to the fourth, and then what goes in front? Oh my gosh. I don't know what's in front. 1/4, and then what goes at the end? Plus c. You guys are used to the fact that usually when you do a u substitution, what do you do at the end?
Plug back in.
Yeah, switch it back. So it really equals 1/4. Your u is x squared minus 2 to the fourth plus c. So to evaluate that integral, you have to do a u substitution because of the chain rule. This right here is a product. Do we have any rules of how you can integrate things with products? No. So if you show up something like this, it's trying to get you to do a u substitution because there is no product or quotient rule for integrals. You have to somehow simplify it. Taking a u is what simplifies it. Yes?
When you got the du, just du, it doesn't matter what's in front of the 2x dx.
Yeah.
And then we got du.
Yeah.
Does it matter what's in front of the 2x or in front of the dx, or is it always just du?
Well, we wrote down our u term, and then what's the derivative of x squared? 2x dx. So it worked out that way for us, that du was exactly what we had.
Okay.
All right, next one. So you know you should do a u substitution because this is a product. It's a product. You can't multiply that in through the radical. So step 1, identify your u. What's our inner function?
T squared plus 1.
Take the derivative of that. 2t and then dt, because we're differentiating it. Like when you take u, differentiating it, a t gets a dt at the end. So these ones are all going to work out really nicely. There are 2 ways to do this. I'm going to show you first the way I think about it. Then I will show you the other way. The way I think about it is not as algebra heavy. It's more just a reasoning of, you guys know in an equation, if you add something, you have to subtract it away to balance it. So I think of it as a balancing way. So what we have is that for sure can just be rewritten as the square root of u. That's not an issue. The issue is we need to get this du in there. For us to switch out and get a du, we need a 2t dt. So we have our t, we have our dt. What are we missing? We need a 2. In order to do that swap out, we need a 2. But since this is an expression, we can't just multiply by 2. How do you balance out multiplying by 2? Yeah, so in front, we're going to put a 1/2. Because we have to balance it out. We need a 2, so we can put in our du. So if we're going to put a 2, so we have our du, we need our du, have to balance it out. So with that 1/2 in front, we put a 2 in here. Now we have our t2 dt. How can I write now? It's just du. So we have 1/2, the integral, square root u. Let's write that as a power. What's the square root of u as a power? U to the 1/2 du. So in order to integrate something, you need the variable and its derivative, which is du. If you have to put something in there, balance it back out. The 1/2 will stay in front. When you do the power rule, what will u equal? So then if it's 3/2 here, what goes in front of it? 2/3 plus c. What's 1/2 times 2/3? 1/3. What does u equal? The book probably won't give you your answer that way. The book will probably say this 3/2 power. What type of root is being taken? Square root. The bottom one is the type of root, and then it's to the 3rd power. So just know that those are equivalent forms. So as you're checking answers, you might have an equivalent form just written in a different way. That 3rd power could also go inside under the root as long as you have parentheses around that t squared plus 1. So what we're doing is we're forcing a u substitution so we can find the integral because you can't integrate if it's a product. I'm going to erase this to do the next one. All right, the next one. What do you feel like our u term is going to be? Something to look for is if you're trying to figure out what your u is, whatever's under a radical, whatever has the highest exponent, things like that. Because now, what's the derivative of that? 4x cubed dx. All right, so this is the way that I don't see it, but I understand some of you might see it this way. So if this way makes more sense to you, go for it. What are we good with here? Like, what do we have the same that matches up? X cubed, so that's good. So our issue is, what does dx equal? Because if we can swap out this dx, we'll be fine. So how can you get that dx by itself? So if we divide the 4 away, 1/4 du equals x cubed dx. So instead of thinking of it as balancing, you can do it as a substitution. We have the x cubed, we have the dx. So I can switch out both of those and instead put what? 1/4 du. So it's either an algebraic substitution of I have x cubed dx, so let's get that by itself to see what it's equivalent to. So x cubed dx is equivalent to 1/4 du. And with the u substitution, then we have a u squared in the middle. You can do it that way because constants and integrals, where can they be moved to? The front. So you can either think of it as, well, I need a 4, so if I put a 4 inside, what do I have to multiply by outside? 1/4. Either way you get there, I think it's easier to think of it as balancing rather than solving an equation and plugging it in.
So the main thing is like you can put it kind of like the way where you can go like the dx or the x stuff the same.
Yep, so once you know what du is, look to see what you need. You have the x cubed, that's good. You have the dx, that's good, so you need to put in a 4. So if you multiply this by 4, what would balance it in front? 1/4. So that's where the 1/4 comes from. What is the integral of u squared?
1/3.
Good try.
So then what do you get in front? 1/12. What does u equal?
How come the C came back? Like I thought we.
Because these ones don't have bounds. So whenever your
Oh,
integral
yes.
doesn't have bounds, it's a very generic integral.
So we do this on the. Did we not do this when we did this the first time?
Yeah, we did plus these the first time because we didn't have numbers on our integrals.
Maybe I didn't do it.
Yeah.
All right, on the next one.
We didn't.
What do you feel like the u is going to be?
16 minus x cubed.
16 minus x
Is it
cubed.
always this obvious or no?
Pretty much.
It's complicated.
Yeah, look in the parentheses.
Well, I
So what is du equal to?
Negative 3x squared. Yes.
So do you guys want to do the algebraic way or the balancing way?
Balance.
Just balancing way.
Good job. I approve.
I don't like that.
no one asked me. I'll show you guys first.
All right. So within this, in order for us to switch out to du, we need a -3, we need an x cubed, we need a dx. What do we have?
X
You have x.
squared.
We have an x squared.
We have a dx.
Yeah.
We have a dx. What do we need?
We need the negative 3.
So if I randomly going to take this times -3, what will balance it out? -1/3 in front. So to balance that out, so I can put a du,
I'll show you the second period.
if you multiply by -3 in the integral to get your du, balance it out in front. When you do this u substitution, it's really going to be 1/u squared.
Why?
Because it's on the bottom, right? Because all of this on top,
So because we have the x squared.
yep, all of that was on top, but your composite function was on the bottom. Your parentheses were on the bottom, so when you switch it out, they're on the bottom.
Are you multiplying by
-1/3. Because if we multiplied by -3 to balance, to get our du on the inside, so how do you balance out a -3 inside? -1/3 outside. All right, next. Do we have anything that we can integrate with that? Or we need to rewrite that u? How do we rewrite it?
U with a -2.
-2. Pretty much all integral rules deal with the power rule or a trig function. So try to rewrite it as a single power. So it's -1/3 u.
-1.
So then what's in front? -1 plus c. So 1/3 u to the -1. Our u is 16 minus x cubed. Since it's a negative exponent, where does it go?
Bottom.
You guys have noticed that a lot of the calc rules, you don't need to simplify down as far as you do in algebra. Like you can leave radicals in the denominator, stuff like that. Negative exponents, no bueno. Make sure you simplify.
No what?
No bueno.
Okay, I stood down.
Take like 5-10 minutes. See what you can figure out on these. So grab your green sheet. See what you can do before I just go through it with you. So like 5 minutes, and then we'll go through them together.
5, 6, you got 3.
It gets canceled out with your du,
I'm
man.
just trying to help you out.
You gotta do this balancing act.
No, I'm not
This
balancing
one
act.
is like this. No, I'm doing it right. No.
See, when you got 6x squared.
No.
I think I got it.
Erroneous. I did it right. What is? I don't know. Don't even. I
I knew I got it right.
No, please.
Alright, the U substitution on the 5 cosine 5x. Once you do the U substitution, what will it turn into?
Sine of.
Oh,
dx sine 5x.
Cosine U
Du.
du.
Yeah, man.
On the next one, once you make the substitution, is this one a straight substitution like the other ones?
Now you gotta do the 1/2 thing.
No, so this is a 2, so what does this guy need?
1/2.
A 2,
You have to show that.
yes,
Like the times two.
no. So 1/2, then,
We got the x on the front.
yeah. So, after you do the U substitution, what is it?
1/2 SU squared du.
Because once you do these U substitutions, are any of these integrals very tricky?
No.
No, and really you're just multiplying by one thing to get it. Alright, on the next one, your U is sine 3x. So then what's your du?
X.
Why is it du?
3.
Cosine 3x.
3 cosine 3.
3 cosine 3x.
Oh, yeah, but then you have to put the 1/3
Main rule. So, how do you know that U should be sine?
Wait, is that science?
Because
So
all
you
that
should
junk
do
is in the
that.
derivative.
I don't know, I can't even read it.
It's sine squared 3x.
Got it.
If you don't know what you're looking for, look for something with an exponent. Something with an exponent is probably going to be configured in it. And also, what is the derivative of sine? Cosine.
So that gets us like that.
So we have that. We have our dx. What do we need?
3.
A 3. So how do you balance out a 3?
1/3.
1/3. So by doing all that substitution, this is really just what?
U squared.
U squared.
U. Boom.
The last one. What's the du?
2x cubed.
6x
squared.
Oh, sorry.
6x squared
Yeah.
dx. So then we have an 18x squared.
Divide.
Yeah, so how do you change an 18 into a 6?
3.
What do you times it by?
1/3.
1/3. So how do you balance out
Oh my
3 and
gosh,
1?
Cassie, are you kidding me?
You choose.
3y? Oh, okay.
I'm gonna get all that out.
So, U substitutions are really the only tricks to let you guys take the integrals of things that look a little bit trickier, because integration rules are pretty basic. A U substitution is what lets you do the harder one. So when you're going through your assignment and you're like, this isn't on my green sheet, you're looking for a U substitution. Make sure you have your du, and then in the end, plug back in.
And then make sure you take the edges so there's no air leaking out of the vents.
Hold on. Last one, what did you do by what? 1/3.
Because we have an 18, but we want a 6. So how do you change an 18 into a 6? What do you have to multiply by?
Like, doesn't have to be like we have a 6, 1, and 18. Does it have to be like the other way?
Nope, you just have to change it so it matches. So if you have an 18 and you need a 6 there, you have to take it times the third. And then what would balance out taking it times the third? Multiplying by 3.
Could you have just backward?
Technically, yes.
Factor
Yeah,
eight
same
into a
thing.
3
You
and
get
a
the same
6.
thing. Yep.
Okay. Nice.
So we still have more?
Factor.
No. All right, page 306, 1 through 59 odd. So as you can see for next week, Monday is going to be very short. Just do a couple more examples. Look to see what things look like on a graph. Tuesday lesson, and then we're reviewing your quiz is the following, or your test is the following Tuesday.
What's the quiz?
No quiz, just test following Tuesday.
Got it.
So we will have 4 solid days of review once we're done.
How nice is that whole day?
No, we'll probably do like a poster day.
Was this?
Oh, a couple work days.
Christmas Day.
Was
You're
it-
doing
A Christmas day.